So here comes the fun part. Now you're a language designer, and as a language designer, you don't really care about what the programmer needs or wants, you just care about what's trendy. And one of the trendiest trends lately is functional programming. So what we're gonna do is design a functional programming language, a very simple one. So you don't really need to know exactly what the functional paradigm is, except that it has these things. So there are no reassignments. All variables are basically constants. You can't do any reassignments like x equals x plus 1. That's forbidden. All the data structures are immutable. So once you create a list, for example, you can't append any element. Once you create a dictionary, you can't add keys, etc. Strings are immutable usually in most modern programming languages. So are numbers. Pure functions. So in most programming languages, functions are actually procedures in that they can modify values outside of them, if they're past a reference to the value, for example. In pure functional programming languages, all functions limit themselves to taking arguments and returning, spitting out a value, and that's the only thing they do. They don't modify anything outside of themselves. You're also going to have lambdas, which is the fancy term for anonymous function. It's basically this guy right here, for example. This takes an x and maps it to x plus 1, right? And then you can use it, you can combine it with a higher order function such as map. And this says, well, take every element from this list and map it to itself plus 1, right? And then you get this list out as a result. Then the last thing is that everything is going to be an expression. And we're not going to have any statements. So what does this mean exactly? Well, what's the difference between an expression and a statement? Well, in JavaScript, for example, things like a function definition, such as this, the classic function definition, are statements because they don't return any value, or they return undefined. Things like throwing an exception are also statements because they don't resolve to a value. They can't be assigned to a variable. If I try doing that, I'll get a big fat error here. So these are statements. They're not composable. You can't build up a bigger statement from a statement, and they don't return any value. Expressions, on the other hand, are composable. So you can make bigger expressions out of these basic building blocks, and they do resolve to a value, right? And they can be assigned. So I can assign expressions to variables, bind them to variables. So everything in this programming language is going to be an expression. So everything is going to be composable, and everything is going to resolve to a value or return a value. Some other cool things about functional programming, these are just side mentions, is that in functional programming, you tend to care less about flow control, basically how and when variables are defined. You care about the logical dependency or dependencies between variables. So this means that expressions can be evaluated lazily when they're truly needed. So if you define a variable at the first line of your program, and then you totally forget about it for the next 100 lines, and then you suddenly remember about it after that, the expression is only evaluated when it's actually needed. So not when you define it. Of course, this is an implementation detail, but it really makes the life easier for the compiler because it can make a lot of decisions and optimizations on your code. Another thing is that expressions in a functional programming language can't do spooky at action. This spooky distant action is a distance things. I can't speak. That means that they don't have side effects, as I mentioned before. That applies to functions and expressions. They can't really act at a distance and modify a distant reference, right, to another object. They just limit themselves to return a value. Since there are no mutable variables, Another interesting thing about functional programming is that you use recursion instead of iteration, because iteration, like for loops, while loops, require reassignment, and since you don't have reassignment, you are forced to use recursion. And you can of course define such abstractions as map, but those are all defined using recursion down under the hood. If you want to know more about functional programming, there's this book I can recommend. But yeah, you don't really need to know anything besides this basic introduction.